Hey everyone, welcome to Pascal's Triangle and the binomial theorem. This is Nicholas JMV, and today we're going to show the relationship between Pascal's triangle and the binomial theorem. So Pascal's triangle is named after Blaise Pascal. Hopefully I'm saying that correctly, but it's actually not his triangle. He didn't come up with it, okay? But it was named in his honor. So Pascal's triangle is a triangle that it looks like this. So the very top number is 1, and then you have these two. The next row here is two side numbers of 1. And important to realize in Pascal's triangle that the first and last numbers are always 1. So if I went to a third row, okay, and now I'm going to add these two numbers together. 1 plus 1 is 2, so I get this middle value, and I get a number on the end. So I kind of leave spaces. My triangle gets pretty big here. So I go another row, so I'll add another 1 here. 1 plus 2 is 3. 2 plus 1 is 3, and then a 1 on the end. So I like to fill in my gaps. So, I have boom plus this gives me that. All right, so, and then I can go to the next row, and I can say, okay, first number is 1, and 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then you get 1 on the end. It's important to realize that Pascal's triangle is symmetric down the middle. So if I go down like this, you see the same things on both sides. Now, how does this relate to the binomial expansion? Well, it's actually pretty cool. So we know that if we expand some binomials, if we take x plus y to the 0, okay, anything to the 0 power is 1, so there you go, you get 1. And then if you did x plus y to the first, that's just 1x plus 1y. Okay, so pay attention to these new values. So then I go x plus y squared. Now this may look like 1 to row 3, but we treat the first row as row 0. Okay, and the reason being is because of that power. So when I look at x plus y squared, if you've done quadratics, you know that becomes a squared plus 2ab plus b squared. So you get 1x squared here plus 2xy plus y squared. Now, hopefully you're seeing some other patterns here. We can go x plus y to the third power, and that's going to be 1x cubed, 3x squared y, 3x y squared, and y cubed. Let's go one more here, and then we'll talk about these patterns. Okay, so fourth power, so you have x to the fourth. Okay, and I like to think the second number in always gives me what row I'm in. Okay, so x to the fourth, x cubed, y, x squared y, 4x y cubed, and y to the fourth. Now, notice how the sum of the powers on each of the variables is always what the power of your binomial you're expanding out is. So 4, 3 plus 1 is 4, 2 plus 2, I forgot a 2 there. 2 plus 2 is 4, 3 plus 1 is 4, and 4. Notice how the numbers in Pascal's triangle are actually the leading coefficients of your binomials. So let's go ahead and expand one here. Let's look at this. So we're going to expand 2x minus 3 to the fourth. So I need fourth row of Pascal's triangle. So you can do plus and negative if you want to. It's up to you. So if I look at it, I need fourth row Pascal's triangle. If I go back, there's fourth row. That's the one I want. Okay, so my coefficients are 1, 4, 6, 4, 1. Okay, so if we can remember that, we would say, all right, 2x, well, we could do it this way. So we had x plus y to the fourth is 1, 4, 6, so 6x squared y squared, 4x y cubed, and plus y to the fourth, 1. There we go. So in this case, we know that x is going to be 2x and y is equal to negative 3. Okay? So now we got to substitute. So it'll take a second to do this. So we could say the expansion of 2x minus 3 to the fourth. So parentheses, you're going to have 2x now to the fourth. Whoops. Plus 4 times 2x cubed times your y. Your y is negative 3. Be careful there. Plus 6 times 2x squared times negative 3 squared plus 4 times 2x times negative 3 cubed plus negative 3 to the fourth. Now I have to simplify this. 2 to the fourth is 16, so I get 16x to the fourth. Okay, plus, now be careful, don't do 4 times 2. 2 cubed is 8. Okay, 8 times 4 is 32 times negative 3 is negative 96, so it's negative, so I could just do plus a negative 96, and that would be x cubed. Notice how my power should be going down by 1. Okay, so I took care of that term. So now we're going to have plus, okay, 2 squared is 4. 4 times 9 is 36. So look, negative 3 squared is 9 times 4. 2 squared is 4 times 6, and that's 216. So 6 times 4 times 9, 216, and then you get x squared. Notice how I have no y terms here because the value for the y is a constant. And then the next term is going to be negative. So negative 3 cubed is negative 27. Okay, negative 27 times 2 times 4 is actually 216 again. So I have minus 216x, right? Just x. And lastly, we're going to have plus 81. That's 3 to the fourth. So that's that binomial expansion there, using the rules of Pascal's triangle. Let's try one more, okay? So let's do the expansion of x squared plus 4 to the third power. So the row 3 of Pascal's triangle is 1, 3, 3, 1. So the idea here is you would have x plus y cubed. So it's 1, so it starts with x cubed. Powers go down by 1 for the first term. So you have x cubed plus 3x squared y plus 3x y squared plus y cubed. Here's our y term, and here's our x term. So let's go ahead and substitute. So we could say, okay, x squared plus 4 cubed is equal to x squared raised to the third power plus 3 times x squared times your y value, which is 4, plus 3 times x squared to the first power times 4 squared plus last term is 4 cubed. So power to a power, that's x to the sixth. Okay, x squared squared, that's x to the fourth. 3 times 4 is 12, so that's plus 12x to the fourth. Okay. Next term here is 3, so it's 3x, so 16 times 3, that's 48. So this is 48x squared, and my last term here is going to be 4 cubed, which is 64. Okay, so that's a couple of examples of how to expand an expression using Pascal's triangle. So if you have any questions or comments, type them below, and we'll see you next time.